Hello, Christine Halsey here, and today we're going to look at how to analyze a BJT amplifier voltage divider bias circuit. Okay, so first we're going to do our DC analysis and look at VB, and that's going to be the voltage divider of R2 over R1 plus R2 times our supply voltage. So we're looking at what's dropped here across R2, or what's left across R2 here. So you're creating a proportionality here of the 15 volts that's left across R2. And we get 2.64 volts. We subtract out the 0.7 volts here, and we have VE at 1.94 volts. To find IC and IE are approximately equal to each other, so we can take our 1.94 volts divided by 390 ohms for 4.98 milliamps. Okay. Then to find VC, which is from the collector to ground, which is just subtracting the voltage across this resistor. So we take VCC minus IC times RC, and that gives us what's left from the collector to ground. In this case, it's about 10 volts. Okay, since IC is approximately equal to IE, VE over RE, so we got 4.98 milliamps. R prime E is going to be equal to 25 millivolts over IE, which is 4.98 milliamps, so 5.02 ohms. We can then find our voltage gain with RC over R prime E. Now a little typo in here, please forgive me. 1K over 5.02 ohms gives us a gain of 199. Alright, for our CSAT Q1, in this example, and we're looking at, I think we were given Q1 was 0.1 volt, so we take 12 minus the 0.1 volt divided by the 10K for 1.19 milliamps. For our CSAT Q2, we subtract the LED as well as the given 0.1 volt, add those two together and subtract that from 12, divide it by the 1K resistance, and we get 1 milliamp. Okay, here we're told to find the beta, so we can solve. We're given certain values here and can use those values to help us find what we need. So for IB, it's 5 minus the 0.7 for VB divided by the 6.8K resistor will give us our IB. IC, same thing, 9 volts minus the 3.2 volts that it's measuring divided by the 3.3K. So we're just using Ohm's law here to solve for these two currents. And once we find the two currents, IC over IB gives us a beta of 27.8. Another example here, so we take the 4.5 minus the 0.7 divided by the 27K for 141 microamps. IC, on the other hand, 24 volts minus 16.8 volts divided by 470, oops, that's not K there, that's just 470 ohms. answer should still be right. I just had a typo. 15.3 milliamps. We divide IC by IB and get a gain or a beta of 109, which is our gain there. Okay. Another voltage divider bias. And we start by solving for VB. Use VB to find VE. Then we use VE and RE combination to find IE. VCEQ, VCC minus IC times RE combo here, including RL. And we get 5.14 volts. IC set, VCC times, and another typo there, sorry, I got in a hurry. So we got 15 over 144 ohms, 15 volts divided by 144 ohms for 104 milliamps. To find our gain, RL over, boy, I'm full of them today, RE1 plus R prime E for a total of 8.57. 100 divided by that 8.57 gives us a gain of 11.7. RN, beta times RE1 plus R prime E, when I copy and paste it, in parallel with R1, in parallel with R2. So that gives us 857 in parallel with 330, in parallel with 1K, which gives us a total of 192 ohms. Our power gain we were looking at here, oh, there's another one, forgot to make that a square, should be AV squared times RN over RL. And this is 11.7 squared divided by 192, or times 192 divided by 100. And that's 263. Trying to check my math there. Yeah, that should be 11.7 squared, not 11.72. My apologies for the typos. All right, for no load, if there's no load, there's no collector current. That means there's no power dissipated by the transistor. The supply, however, would create a Thevenin equivalent circuit. The Thevenin resistance would be 248 ohms. RL plus RE2 is 44.2 ohms. And our V Thevenin is 3.72 volts. So that and the diode, we use the voltage divider here to find the voltage across the 44.2 ohms, subtracting out the 0.7 volts for the diode. Then we can find VE and then add in the 0.7 for our 1.2 volts that we find for VB. ICC is then equal to VC minus that 1.2 volts divided by R1, which gives me 13.8 milliamps. So here our total power, ICC times VCC. I think that should be my IC. Boy, I am full of mistakes today. IC times VCC. So our IC was 13.8 milliamps times the 15 volts is 207 milliwatts. The signal power in the load with a 500 millivolt input signal, so we have our gain is 11.7. The voltage ends 500 millivolts peak to peak. which is 177 millivolts RMS. So our V out is going to be our gain times Vn, which would give us a V out at 2.09 volts. The power would then be the voltage output squared divided by RL, which gives us 43.6 milliwatts.